So by the time it actually scales, already 10 or 15 minutes have passed, right? So which is might be seen as a problem, right? It's we don't always want to wait for that long.
Hi everyone, this is Ishwarya Goyal
And I'm Nilesh Agarwal.
from Towards Scaling Inference. Towards Scaling Inference is a place where you can learn about ML deployments from zero to scale. We are very excited to have Saulius from Dun Bradstreet with us today. He's an accomplished machine learning engineer with an MS in computer science, currently serving as a principal engineer at Dun Bradstreet. He's an enthusiastic self-starter, interested in AI, machine learning, computer vision, NLP, and brain-inspired pattern recognition algorithms. Thank you, Saulius, for joining us today.
Thank you. Nice to be here.
Great. So we would like to start the interview by first understanding that what kind of business problem are you solving through AI?
I've worked on several AI and machine learning projects. Right now, currently, the business problem is this. Essentially, our customers have a lot of clients, customers, and leads of their own. So they are big companies, and they're thinking how to market their own products or services to those customers or to those leads. So essentially, our machine learning models try to predict which leads or which accounts should be focused to do the further marketing and outreach efforts too. So essentially, we have a whole bunch of attributes gathered from all different places about these business entities or leads, and the model is trying to identify those who are likely to become either customers or likely to become repeat customers or likely to spend more money on that certain product and so forth. And then this helps advertisers and marketers focus their efforts and their time on those specific leads or customers.
Got it. Got it. And how do you currently deploy these models in production? So do you work with managed services like AWS, Hugging Face, or have you built your own ML infrastructure from stack? And would also like to understand the pros and cons of the approach you have taken.
Right. So in general, I can only talk in general, and I've deployed models in several different environments. Starting from completely home-based solution, which essentially has deploys its own servers and its own homebrewed architecture, and also going through the scikit-learn models that also require their own machine to be provisioned and or a cluster of machines and do inference that way, and then going to the SageMaker models in AWS, where we deploy the SageMaker models to the SageMaker provided infrastructure, to the SageMaker endpoints and so forth, and then allow AWS SageMaker to manage the load and to scale in and scale out the endpoint infrastructure behind the scenes. So that is of course an automated, more automated solution, which I like. There's not if we're able to automate it and delegate these tasks to the AWS SageMaker, then we set the scaling parameters once and we can can be sure that the SageMaker is going to take care of the load and so forth. So currently I like this approach. It looks like this is where the industry is going towards this automated approach, and also it's not limited to just AWS or just SageMaker. I mean, if you choose any other machine learning platform, such as GCP, right, and so forth, you would find some similar functionality and similar approaches there. So that's why I think that this is a big pro of this approach. If you configure that right, you can set it and forget it, and essentially let someone else take care of the scaling and inference.
Got it. Oh, that's super awesome to hear. And just wanted to understand in terms of your inference workload, right? Are they more like real time, batch, like, and what are the challenges like when you like deploy it with SageMaker, especially like in terms? Yeah, I would love to understand that part a little bit more. Yeah.
The inference workload, yes. So yes, we do have. I worked a little bit on real time, and also the batch processing, definitely. We not as much for streaming type of data, because pretty much we don't have that kind of data. But yeah, so for example, for batch processing, there are several ways to do it, and for example, in SageMaker, it offers batch processing jobs or batch transform jobs, where you spin up a separate AWS instance, and that will take care of all of the batch processing. Once it is done, it will shut down that instance and you're done, right? So that's one approach. Another approach, even for the same batch processing, is to rely on the SageMaker endpoint, which is always there. It's always there behind the scenes and available. And if the batch processing request comes in, you can just send it to the SageMaker endpoint and let it handle this load of batch processing, no matter how big that load might be. And the challenge is of course to set the parameters of the scaling, and to test that scaling, so that you're sure that it's going to support the workloads that is likely to happen or to occur. So I've had a number of challenges with actually making sure that we can support the load that's coming from quite a big data that needs to be run through the models and scored, and kind of leveraging both approaches, the batch transform jobs and the endpoint based inference. Currently, I tend to think that endpoint based inference is more promising approach. Because then you can start the inference right away and rely on the scaling functionality in that endpoint itself.
Got it. No, this is super helpful to understand a little bit more about how you guys like deploy your inference workloads. Just a follow-up question here. What are the model types that you have? Are these like prediction-based, generation-based, like, or is it like classification? What kind of models, like, what are the kind of tasks that you perform with these machine learning models?
Yes, so as I said, essentially we are trying to predict whether a certain contact or customer is going to either convert to a customer or purchase more product, right? So this is clearly a supervised machine learning, and this is certainly a classification problem. So we use classification models to predict this event, whether or not it's going to be a successful new customer, right? Well, also we can use regression models as well. Regression models might predict not just whether or not this lead is going to become a customer, but once they become a customer, how much money they are likely to spend on the certain product or service. So this is where regression comes in, right? It's not just a discrete value. This is prediction on the on the whole range of values, right?
Got it. So I understand, based on, since you're working with classification and regression-based models, I'm assuming all of the inference workload runs on CPU, or do you also use GPU to run your inference workloads?
Well, I think we thought about GPU, and this is something that might be enabled because I think AWS SageMaker allows to switch the models, basically to specify whether we want to use a GPU or not. So even though we might be using CPU, there is a way to quite easily switch to the GPU and inference and see if that makes any sense, if that really improves the performance and is cost effective as well.
Got it. But currently, like your majority of your infrastructure, like what is the percentage split between CPU and GPU for current set of models?
Well, right now I haven't started investigating this GPU alternative. Let's say this way, but using AWS SageMaker, I think this is not that difficult of a task to switch between the two.
Got it. And no, got this point clearly. And do you guys also have a like optimization pipeline before you deploy the model to inference, where you run quantization or anything just to get the right amount of latency and like utilization of the resources?
Well, I don't. When you're talking about the pipeline, I'm not sure if we have like an automated pipeline that would evaluate this. But certainly, I do evaluate the the latency, the resource utilization, and the overall ability to handle the load before deploying any solution to production. Right after the solution is deployed to production, it is up to our customers to train their models, to deploy them, to use them, and so forth. Right. So we might have an increasing number of models that are actually running in production as our customers keep training those models and keep deploying them. But before all of that happens, of course, we have to test all of that in-house to see how many models can we support. Do we have enough infrastructure to support it? Is it going to scale to the certain amount of models, or to the certain amount of data that needs to be run through prediction for those models?
Got it. No, got that part. So just wanted to understand, especially when you talk about, let's say, scaling the infrastructure, right? So just wanted to understand, like for infrastructure, how do you guys go about manage costs, right, while it's scaling? I understand that with the SageMaker, you guys are setting up the scale factors, right? But does it often happen that, let's say, because of scaling up, some customers have a degraded experience because as your model takes time to get load, right? So are there challenges in that area where you would prefer like more of a serverless solution, or do you think the current infrastructure with SageMaker is pretty seamless for you guys?
So let's talk about two use cases, because for real-time scoring, I agree that yes, this is essential to give the answer pretty quickly and to respond in a reasonable time, right? So for real-time scoring, we might have a SageMaker solution that provides enough hardware, enough endpoint capacity to actually do that, to handle the load, and we can monitor that load, ourselves, whether or not the endpoint is fully loaded or half loaded, or should it be scaled and so forth. But on the other hand, let's say for batch processing, if a customer does a batch processing with quite a big data, they run this batch processing, which includes model scoring, but it includes many other steps in the pipeline as well. So they might wait for quite a long time for this to finish. And of course, one component is using the model for prediction and so forth. So we still have to think about and manage the time it takes for the model prediction part to finish, and make sure this is within reasonable limits. But we can then afford, let's say, to wait until the SageMaker endpoint actually scales up, because this takes time, right? It takes time. At least 5 minutes to even detect the need to scale up, and then another 5 or 7 minutes to actually add another instance to the SageMaker endpoints. That this is how the SageMaker endpoint works behind the scenes. It just takes time, right? So by the time it actually scales, already 10 or 15 minutes have passed, right? So which is might be seen as a problem, right? It's we don't always want to wait for that long, and in some cases, by the time it scales, the whole inference job is already over, right? So there are problems like this, but I think for now, this can be done pretty seamlessly to the customers who rely on batch processing.
Got it. No, I totally understood the part. So you're saying for real time, still you would like a service which scales like in like couple of seconds rather than like taking 10 to 15 minutes, because that will help you give a better, more reliable solution to your customers, right? Is that a correct understanding?
For real-time scoring, well, yes and no, because yes, I mean, it would be great if it scaled within a couple of seconds, as you're saying. I don't think right now SageMaker provides any kind of solution like that, right? But on the other hand, if we do the real-time real-time inference, we can usually predict what the load is going to be, because the real-time inference is not coming in huge batches, right? It comes, a few or dozens of records at a time. So we can monitor that load. And if we say, okay, now the endpoint is loaded too much, we can do the scaling, and then the load becomes slower. But it's not that we have to do it over and over and over again. This is not an this should be a rare event, right?
Got it. No, that's super helpful.
Mm-hmm. Right.
Yeah. And one last question, Saulius, from our end. So can you discuss any best practices or tips for other ML engineers who are looking to deploy their models in production based on your experience?
Right. So yeah, general tips. Deploying is always difficult, and whatever you see the model performance in your development environment, it might be completely different from what you're likely to see in production. So therefore, I would like to emphasize the need of testing and retesting at each and every stage of development, starting from your prototype, when you're starting to prototype the models. Even then, we need to do some kind of estimates how much load this solution is going to be able to handle, right? And then of course, after the solution is already implemented and ready, before deploying to production, again, we need to thoroughly test how this is going to handle the load. The way to do that, it would be great to have the same kind of infrastructure in the QA environment or in your testing environment as is going to be in the production environment, and then test on this kind of infrastructure, and like try to do the same kind of loads, the same kind of scenarios with as big the data as possible, and see how that is handled by the prediction and inference infrastructure. So then we can avoid bad surprises, once it is actually deployed to production. So that's basically my main takeaway.
Got it. No, I think this is really insightful, and all the answers that you shared, I think would add like a lot of value to engineers who are looking to deploy their models in production. Again, thank you so much, Saulius, for taking out time for the session. It was really great hosting you with us.
All right, thank you very much. It's been a pleasure talking to you.